Newton's first law of motion and Galileo's assertion. This explains the subtle distinction between Newton's first law of motion, law of, law of inertia, and Galileo's assertion that force is not necessary to sustain horizontal motion. Newton's first law of motion, inertia. An object at rest remains at rest, and an object in motion remains in motion at constant speed in a straight line unless acted on by an unbalanced force. Newton's first law states that every object will remain at rest or in uniform in a straight line unless compelled to change its state by the action of an external force. This tendency to resist changes in a state of motion and in a state of motion is inertia. There is no net force acting on an object if all the external forces cancel each other out. Then the object will maintain a constant velocity. If the velocity is zero, then the object will remain at rest. If an external force acts on an object, the velocity will change because of the force. So here I have two examples. So first is the stone. So as you can see in my example picture, there is a big man carrying a huge or a bulky stone. Inertia is there another term for laziness. Lahat ng bagay na nasa paligid natin na nakikita natin ay tamad. Hindi gagalaw unless you will put force on them. So, ang stone na to ay hindi siya magagalaw from that place to another if this man will not carry the stone. The second one is the ball. So, yung ball na to sa larong football, hindi ka makaka-goal if you will not play, if you will not kick the ball to the goal station. So, paano ba mapapahinto itong mga object nito na nilagyan mo ng force? So, I have 3 here. So, first is the wind. So, paano siya napahinto ng wind? Kapag different direction sila. Kunwari, sa bola, if the ball is going through from left to right, and the wind is from right to left, there is a chance na mapatigil ng wind yung bola kasi magkasalungat sila ng direction, and wind can also be a force to stop the ball from rolling on the ground. Second one is the ground. Paano nga ba? If the ball is rolling on a flat surface, hindi na siya magko-continue. Why? Kasi hindi naman nakadepende siya. Hindi naman siya nakaslant or whatever. Flat yung surface na example. So, nasa flat surface siya, hindi siya magko-continue mag-roll. There is a chance na titigil yung bola dahil wala nang na-exert na force sa kanya. So, the third is the obstacle. On my second example, ang football game, napapahinto ang bola through the net. Yung net po na pinapasukan ng bola para masabing naka-goal itong team na to. That is an example of an obstacle na magpuput ng force para mapahinto yung bola from moving. So, another Let's move on to the next, Galileo's assertion of inertia. So si Galileo, kay Galileo na conception ng inertia is friction. So, slope downward, speed increases. Slope upward, speed decreases. So, kapag itong nasa first na nasa first in line is pantay sila, 'di ba? Pantay po sila. So, sinasabi ni Galileo na kapag ganyan sila, mas mabilis or pantay yung galaw ng bola. So, here, sa second, kapag ganyan po yung place na or yung position ng initial position to the final position, medyo babagal. Kasi yung nasa final position is mahaba na yung i-go through nung bola. So, dito naman po sa pinaka-last, so, from the initial position to where is the final position, wala nang obstacle. Hindi na siya nakaslant na pataas. Straight na siya from the initial position. So, paano na siya? Sabi ni Galileo is, ang assertion niya is friction. Because of friction, ganyan po. Difference between Newton's first law and Galileo's assertion. Kay Newton, yung push cart, hindi siya gagalaw unless you push it, unless you put effort, unless you put force on it para ma-move mo. Kay Galileo, gagalaw na ng kusa ang object dahil sa friction. So, inertia refers to the tendency of any material to change its state of motion. Galileo asserted that if a rolling ball was alone, it will continue to move with constant velocity. The only difference between Newton's first law of motion and Galileo's assertions is their concept of force. So let's move on to another topic. Propagation of light, reflection, and refraction. So, light propagates in transparent or weakly absorbing media by inducing the atoms or molecules in the materials oscillates in response to the electromagnetic field of the light. So, light can travel in three ways from a source to another location. So, first is directly from the source through empty space. Second is through various media. And third is after being reflected from a mirror. So, first is reflection. Ang reflection is nagbabounce. So, kunwari, ang flashlight, tinampat mo siya directly sa mirror, magbabounce ng same din ng position yung reflection ng light sa iba pang space dun sa bahay na yon. Ang reflection ay balance sila na so as I was saying, sa reflection po ay equal sila. So, kunwari, ito yung light from the light source. And then, nandito po, ayan, yung line na yan. Yan, yung line po na yan. So, kunwari, nandyan po yung mirror. Ang reflection po ay equal lang sa kanya. Hindi nakaganito, hindi nakaganyan. equal po sila palagi sa reflection. So, sa refraction naman po ay hindi po ganon. Baliktad po sa refraction. So, mapapaliwanag pa po natin. Light sa wave model and particle. Particle model of light predicted that the speed of light would be faster than in air, and the wave model predicted the opposite. So, eto, meron po akong example dito. So, nandito si barrier, andito si light source, and this is the particles. So, kapag particles po sa light ha, kapag particles po ang pinag-uusapan at naharangan ni barrier, maa-absorb lang po siya ni barrier. Hindi po siya tatagos, hindi siya magbabounce or whatever. Ia-absorb lang po siya ni barrier, and then the rest is magta-travel na siya doon sa buong empty space na yon. Unlike K-waves, andito si light source, si barrier, yung waves po ay magbabounce or gagawa pa siya ng way para makatagos doon sa barrier. Doon nangyayari yung shadow nung light doon sa barrier. Hindi siya maa-absorb. Gagawa siya ng shadow or iikot siya. Ganon po sa waves. Second is reflection. Sa reflection, as I was saying kanina, both the particle and wave theories adequately explain reflection from a smooth surface. However, the particle theory also suggests that if the surface is very rough, the particles bounce away at a variety of angles, scattering the light. This theory fits very closely to experimental observation. So, I was saying kanina, ang reflection po is equal sila. Sa particle, equal. Sa wave, equal din po. So, third is the refraction. So, sa particle, opposite force pulls particles from medium, and wave edge bends at the entry. So, same po sila. Kung ang refraction, ito si source of light, and then kunwari ito si barrier. Ganyan po si barrier. Ang reflection or ang refraction po ni light source is nakabend or hindi nakapantay kay light source. So, parehas po sila ni wave model and ni particle model. So, let's move on to the photon concept. Photon concept and the fact that the energy of a photon is directly proportional to its frequency. Photon is the smallest discrete amount or quantum of electromagnetic. It is the basic unit of light. Photographic paper reacts to light to produce the image taken by a camera and is stored on a film. Dark rooms use red lighting to allow photographers to control light carefully so that light-sensitive photographic papers would not become overexposed and ruin the pictures during the developing process. When ultraviolet or UV lights hits our skin, the DNA in our skin cells will undergo chemical change because ultraviolet or UV lights is the extreme level than the basic light that we feel. So, doon nag-start na mag-sunburn po tayo, ganyan. Kasi nga, mas extreme pa siya doon sa basic light lang ng balat natin. Na-absorb ng balat natin. So, how we see colors. The human eye and brain together translate light into color. Light receptors within the eye transmit messages to the brain, which produces the familiar sensations of color. Newton observes that the color is not inherent in objects. Rather, the surface of an object reflects some colors and absorbs all the others. We perceive only the reflected colors. So, sa mata natin, meron doong wall that is the thin layer in the back of our eyes, which is called retina. And then sa retina, meron tayong dalawang detecting cells. Ito yung which is the cone. The cone is this one. Red, which detects color red, green, and blue. While this one called rod, it detects no life or black and white. So, kunwari, nakakita ka ng color yellow. Hindi siya literal na yellow na nakikita mo. Paano mo nalalaman na yellow yung color na yon? Which is, nagko-combine si color green and color red, and sila mismo yung nagsisend ng information sa brain para masabi na color yellow yung nakikita mo. So, let's go on to the next. Hertz produced radio pulses. Hertz apply high voltage electricity across the central spark gap of the transmitter, creating sparks. The sparks cause violent pulses of electric current within the copper wires, leading out to zinc spheres. And as Maxwell had predicted, the oscillating electric charges produce electromagnetic waves, radio waves, which spread out at the speed of light through the air around the wire. Hertz detected that the waves with his copper wire receiver sparks jump across its spark gap, even though it was as far as 1.5 meters away from the transmitter. These sparks were caused by the arrival of electromagnetic waves from the transmitting generator, generating violent electrical vibrations in the receiver. This was an experimental triumph. Hertz had produced and detected radio waves. Thank you so much.